Welcome to lecture number 15 of chapter 4 series. So here I am going to continue the exercise. The first question for today is question number 4.19. The question is like this: the first order reaction takes 40 minutes for completion of 30% reaction. Calculate T1 half. Okay, so in the question, first order reaction is there. Now it takes 40 minutes for 30% decomposition. So here I have written that 40-minute time is required for 30% decomposition. Means 70% of reactant remains as such, only 30% that decomposes. Now suppose initial concentration is 100. After 40 minutes, concentration of remaining reactant that remains 70%. So here I have written 70. Now for first order reaction, the differential rate equation is here: 1 by K into ln R0 by R is equal to T. Now we have time T here, 40 minutes. So I have put that value in here. R0 means initial concentration that we have taken 100, and R that is 70 into 1 by K. Now convert ln into log, so multiply it by 2.303. 1 by K that is as such. Now this division, 100 divided by 70, you will get 1.42 is equal to 40. Now if you solve log 1.42, that is 0.1522. Now what I am doing here, changing the side of K and 40 here. So K will be here and 40 it will come in division here. So you will get K is equal to 0.00876 minute inverse. Unit of K, that is inverse of time T. Unit of time T. The unit of time T was minute. So here inverse of that minute is there. Now we want to calculate half-life. So for first order reaction, half-life is given by this equation. T1 half is equal to 0.693 divided by K. Now we have K value here, just put that value in the equation. 0.693 divided by 0.00876. You will get 79.10 minute. Next question, 4.20. The question is like this: for decomposition of azoisopropane to hexane and nitrogen at 543 Kelvin, following data are obtained. Here a table is given to you. Time T is in second and pressure is given to you here. So we have to calculate the rate constant. Okay, so here total 3 time are given to 0 second, 360 second and 720 second. So first 0 to 360, for this time interval we are going to calculate K. Then for 0 to 720, for that time interval we are going to calculate K value. So we will get 2 K values here. After that, take average of that 2 K value. So you will get rate constant of overall reaction. Again, first for time interval 0 to 360, that K value we will find out. Then time interval 0 to 720, for that time interval we are going to find out a separate K value. So we will have 2 K value here, and in the end we are going to take average for overall rate constant K. Okay, so first decomposition of azoisopropane to hexane and nitrogen is given by this reaction. You can see here the formula is written. This is formula of azoisopropane. Now it decomposes in hexane C6H14, that is hexane, and nitrogen gas. Now suppose at time t is equal to 0, the initial concentration that is given to you, initial concentration of this compound azoisopropane is P0. Initial concentration means reactant is not formed yet, so pressure of nitrogen, that will be 0, and pressure of hexane, that will be 0 here. Now at time t is equal to t, suppose after some time some pressure of reactant converts into pressure of product here. So suppose that pressure is P, so remaining pressure of reactant, that will be P0 minus P. Why P is minus? Because it is used to convert in product. So pressure of product here is P and P. Nitrogen pressure P and hexane pressure, that is also P. Now at time t is equal to 0, total pressure if we calculate, so you can see here total pressure P0 plus 0 plus 0. So initial total pressure is P0 only here. Okay. Now at time t is equal to t, total pressure is suppose Pt. Now you can see here total pressure is P0 minus P plus P plus P. So here it is written. Here it is written, total pressure Pt is equal to P0 minus P plus P plus P. So total will be P0 plus P. So here Pt is equal to Pt, that is pressure at time t, total pressure at time t, that is equal to P0 plus small p. Now from this formula, if we want to make formula for small p here, so small p is equal to Pt minus P0. Now here you can see the remaining reactant that have pressure P0 minus P, P0 minus small p. Now in that equation put the value of P that we found out here, this value. So P0 minus P is equal to P0 as such minus in bracket Pt minus P0. So you will get 2P0 minus Pt, because minus minus will be positive here. Now initial pressure, that is P0, initial total pressure we found out, that is P0. Final pressure of reactant only, again final pressure of reactant only, that is given by 2P0 minus Pt, this value. Now for first order reaction, the differential rate equation is here. Here instead of R0 I have written P0 and Pt, because our reactant is in gaseous state. If the reactant is in gaseous state, then instead of concentration we can use pressure here. So here P0 and P is pressure. Okay, remaining terms are same here. So if the reactant is in gaseous form, then use pressure term instead of concentration. Now you can see here K and T, I have changed their places here. 1 by T is there and K is here. Okay, now at time T is equal to 360 seconds, put the values here. First of all, 1 by T was there, so 1 by 360 into ln P0, that is initial concentration. In the table it is given that initial concentration is 35. Okay, here you can see the initial concentration is 35 and time at time 360 seconds the pressure is 54. So that value we are going to use here. So here instead of P0 I have written 35, and instead of PT we can write this one, 2P0 minus PT. Now P0 is 35 and PT that is 54. So put that values here. You can see here it is written. Now just solve this equation. Convert ln into log, so multiply it by 2.303. This will give you value 14. So log 35 divided by 14. Now that logarithm value will get 0.3979. Now after solving this you will get 0.00254 second inverse. That is our first K value. Now similarly for time T is equal to 720 seconds, the value is given to you. For time interval 0 to 720, so you have to put 720 as time T. P0 will be same 35, and in the division you have to write 2P0 minus PT, means 2 into 35 minus 63. That value you have to put that, and you will get second K value. After getting that second K value, you have to take average of that both K value, that is rate constant for overall reaction. So complete the example. Okay, thank you.